Good afternoon, dear students. Welcome to another session of Verilog HDL. So, in the previous session, we started off with the discussion pertaining to behavioral modeling. So, in that, we discussed different concepts related to structured procedures, that is, initial and always statements. And then we discussed regarding the procedural assignments, in which we saw different kinds of assignments, that is, blocking assignment and non blocking assignments. Then we came around with time controls. Okay, so this is what we have to start off now. So we started off discussion with the timing controls. So under the timing controls, we started off discussion related to the delay based controls. So in which hash is used to specify the delay. In that, we have three formats: hash number, hash identifier, and hash mint or typical max expression. Or you can have any other expression pertaining to a similar kind of thing. Okay, so this is how it goes around. So in that, you have the regular delay under this. So in this regular delay, what you do is you specify on the left hand side of the assignment operator hash the number or the identifier or the expression. So here there is a number specified. Here latency is a it is an identifier, and this side you are using identifiers itself as an expression in order to identify the timing controls. Here y is also an identifier, so for that purpose also we have it also has been used as a delay parameter. Now this is your typical this is min, typical, and max expression. So this is what you had studied during the rise time, fall time, and turn off time. So that is what we had discussed. So this is your pertaining to your minimum value. This is a maximum value, and this is a typical value which will be applied to that rise time, fall time, and the turn off time, depending on which one you want to apply. So this is just the declaration, and once you use it right, which delay you want to use, so that can be specified in the other statements. So this is pertaining to regular delay control. Then we came across another one, that is intra assignment. That is, you have the delay specified in between the assignment operator. So here what happens, on the right hand side of the assignment operator, you have the delay specification. So there is one uniqueness with respect to these two. In this one, what happens is, for example, if I encounter this statement is encountered at zero time unit. But when is the assignment done? Assignment is done, in this case, it is done after 10 time units, because you have a hash 10 over here. So one is taken and assigned to y. So that happens at 10 time units. Now here, so if I come to this one, right? If you just observe, what happens is, I encounter this statement at zero time unit. But what happens is, the assignment actually happens, and the evaluation of this expression also happens at after y time units. After y time, because it is hash y. So at that moment, x plus 1 gets evaluated, and then it gets assigned to x. So this is what is happening. But in case of intra assignment, right, what happens is, the statement is encountered at zero time unit. The statement is encountered at zero time unit, because it is concurrent in nature. So at zero time unit, the statement is encountered. At that moment, what happens is, this expression which is there, that is x plus z, what you are specifying. So this gets evaluated at zero time unit, at zero time unit. But the value what you have obtained for x plus z, right, that is this expression, it will be assigned to y only after 5 time units of delay. Only after 5 time units of delay. And in between, if say in between 0 to 5 time units, so what had happened at 0th time unit, you have evaluated this expression. This expression was evaluated. In between 0 to 5, if something happens to x, if changes happen to x or y, those values will not be affecting the first result what you have calculated. Okay, so that will be retained, and then it will be stored. Okay, so the similar equivalent he has just specified for understanding purpose. What you have x is equal to 0, y is equal to 0. Then it is like at time t is equal to 0, you evaluate x is equal to, sorry, temp x comma z is equal to x plus y. So you evaluate that, and after 5 time units of delay, you assign that expression value to y. So this is what is happening. So this is how it goes around. Okay. So this is just an analogical representation for, in a simplified form, it is representation for this one instruction. This one instruction which is there, right? So this is how it appears. Okay. So moving further, we discussed another one, zero delay control. Now, why the delay control comes is in a few of the instructions you want it to be executed at the end. Say after some 10 lines of codes has been executed. Say for example, I want to execute these two, x equal to 1 and y equal to 1, after all the other instructions are executed. So then in that case, what we do is we specify hash 0, hash 0. So when it is specified as hash 0, these statements are the last to be executed. These statements are the last to be executed. So therefore, what happens is after the execution is complete, I know that x is confirmed it is 1, and y is also confirmed that in this case it is 1. But if hash 0 was not there, then this confirmation I cannot give, because we don't know which one gets executed initially. All start at time unit 0, but I don't know which one will be starting the execution. So these things we had discussed in previous session. So next one we have event-based timing control. Event-based timing control. So now Verilog actually permits me to declare some events and then go ahead with using those events for triggering for the timing. So here, what does the event mean? Event is nothing but whenever you see a change in the register or the net data type, so that incorporates for an event. Whenever you see a change in the register or net data type, you encounter an event. So these can be utilized for some purposes. So let us see the examples pertaining to these. Before going into that, we have actually four types of event control. One is your regular event control, one is your named event control, and the event or control and level sensitive control. So let us look one by one at these aspects. So your first one, regular event control. Now, if I have to specify an event, right, at the rate, the symbol is used to specify an event control. That is, at the rate symbol which is there, it is used for the event control information. Now, how that is used, we'll check in the examples. So, whenever there is any change in the signal values, right, then that time it will trigger an event, and accordingly the changes will be happening. So here, one important thing to remember for these regular events, right? Say up to regular events, named event, and event or control. So these are a kind of positive or negative edge trigger. So if you have a timing diagram, this is a positive control. This is a positive control, and this side is the negative edge control. So during the rising edge or the falling edge. So that is what it pertains to. So event is triggered only during those points. Okay, that is either during the rising edge or during the falling edge. So we call it as either positive edge or negative edge. Okay. Therefore you have these terms, that is during positive or negative transition of the signals. There will be changes happening. So here we can observe that example we have at the rate. So this indicates that this is pertaining to a event. So whenever there is a change in the clock, say whenever there is change in the clock, then you execute the statement. So whatever statement or statements are there has to be executed. This will be running only whenever there is change in the signal or the event which is specified over there. So again, apart from this, you can specify that at the rate, that is during the event of positive edge of the clock, that is when there is a rising edge or the positive edge. So that time we can execute the statement. So this execution happens when you see a positive edge. So when do you see the positive edge transition? When you're moving from 0 to 1, or you are moving from x to 1, or you are moving from z to 1. So any of these conditions can be there. That is what x or 0 to 1 is specified over here. So either 0, x or z. From that point, you move to 1. That is the clock moves from those condition to a logic 1. So that time this event gets triggered. Now in the negative edge control, right, what happens? It is the reverse. That is you move towards 0. That is logical 0. So for example, you have 1 to 0, or x to 0, or z to 0. So under these conditions, the statement gets executed. Now here we have slightly different notation. In this, what happens is D is evaluated immediately, and then it is assigned to the value Q, which is present over there after during the positive edge of the clock. D, that is immediately D value is estimated. Once D value is estimated, it will be holding that value. Once you see a positive edge clock, right, that time what you do is you go and assign it to Q. So this is the minor change which is present over here. So at the rate is used for what? Event information. So clock is the event. So whenever these events change, in this case, whenever these events change, accordingly the statements get executed. Okay. So you can have just the clock, positive edge, negative edge, and slight differences. Immediately you consider this D value, evaluate it, and then assign it during the positive edge of the clock. So this is what is happening in this case. That is a regular event control. Now next we have a named event control. Now Verilog actually helps you to provide or declare the event and then use that as a trigger. So these kind of events can be seen, say, in your networking. Suppose there are a transmitter and a receiver. Suppose there is a transmitter and a receiver. Now, what happens is, suppose this transmitter is sending packets. So when you come to communication, right, networks, that time you can get to know that we'll be transmitting the data, say, in terms of packets. So when you're transmitting these packets, so receiver has to see that whether any packet has arrived or not. So this is like an event for the receiver. This is like an event for the receiver. So whenever it receives a packet, it has to perform some activities, or it has to perform some task over there. So it is waiting for the event of reception of a packet or a frame or bits. So that is what it is waiting for. So such kind of activities can be modeled even in hardware description language. So here what happens is, here we can see through an example. What he is specifying is, event is the keyword. Event is a keyword to declare that there is a event of declaration. That is, you declare an event using the keyword event. So received data is the event which is being declared or which is being defined. Okay. So now based on this event, right, we can perform some activities. Now here we have always at positive clock edge. So always make a check during the positive edge of the clock. Whenever there is a change, so execute this part. Now here what he is doing is, if last data packet is received. So what he is doing is checking whether the last packet has been received or not. If last packet is received, then what he is doing is he's triggering this event what he has declared here. So received data is an event. What you're doing is you are triggering this event. So how you are triggering this event? You are making use of this operator. You are making use of dash and a open angle bracket. That is arrow kind of operator what you are seeing over here. So this operator is used to trigger the event what you have defined. So this is the event which you have defined, and this operator is utilized for triggering that event what you have declared. This is the named event. That is, you declare an event or define an event and use that identifier for triggering the some activities. So the symbol which is used for triggering that event is say a minus sign with the open angle bracket or a dash sign with the open angle bracket. Okay, so now at the rate symbol is utilized in the same way. Now what you have done is you are just checking whether you have received the last packet. If you have received the last packet, then you trigger this event. Then you trigger this event. So what is happening here is you have a receiver and you received this last packet. You received this last packet. So now what receiver does is it gets to know that okay, I have received the last packet. Therefore, you trigger this event. You trigger the event specifying that it is received data. Okay. So once you trigger this event, you perform the activity whatever is required. That is, here we can observe that we have always at the rate the event what you had defined previously. So this part gets executed only when this event is triggered. If this event is not triggered, this part won't be executed. So you are waiting for the end of the last packet, event gets triggered. So if this event is triggered, this statements get executed. So in this one, you might be storing that data. So here what he is doing, he is storing that data packet 0, 1, 2, and 4. He is concatenating all and storing it in the buffer. So that is what he is doing in this case. Okay. So next we have event or control. Event or control. So now why is this required? Now in some cases what happens is, say you have to execute or perform some task based on whether one event has occurred or not, depending on multiple events or multiple signals changing. So if any one of them changes, then you have to perform some task. For example, if I specify, uh, say say you have say a multiplexer, for example, you have a multiplexer and you have select lines s0 and s1 and there is an output. Now based on these values and these 0 1 2 and 3, so based on this the output will be present. Now here what happens is, if you just observe, if either s0 or s1 or any of these parameters change, any of these parameters change. So here you can see that it is possible that this can change, or any of these can change. So if you just check, there are four possibilities here and two possibilities here. So if this is the case, then in any of these cases, whether only S0 changes or whether only S1 changes or whether both change. So in such conditions, what happens is the output has to alter based on what changes have occurred. So here what is happening is you are seeing that multiple events are triggering this entire activity. So it is triggering this entire activity. So in such cases, we require multiple tracking over there. So this is how we can go ahead with using event or control. So we make use of the keyword or for these cases. So let us look at this one using a example. And the list of events which are present, right, with the or expression, they are called as sensitivity list, because your entire any of the list changes, then it triggers the entire activities which follow it. So for example, here you can see that you have always at the rate. At the rate implies that next is all the events. So either reset changes or clock changes or D changes. So or is the keyword here. So if any one of these events change, any or in any combination they can change. If any one of them changes, then this entire part of the code gets executed. This entire part of the code gets executed. If none of them change, then this will not be executed. So here what is happening, he is just taking an example. He's checking if reset is pressed. If reset is pressed, make q equal to 0, or else check if clock has changed its value to logical 1. If yes, then you put the d value in the q value. So it is nothing but a delay flip-flop what he has implemented here. So whenever reset changes or clock changes or d changes, you make the changes in queue accordingly. You make the changes in queue accordingly. So this is how it goes around. Now we also have another option that instead of using or, we can use a comma. Instead of using or, we can use a comma over here. Now here, this list which is there, that is reset, clock, and D. It is called as sensitivity list. It is termed as sensitivity list. So now next one, so up to this point, if we just observe what is happening is, here we could observe that in the regular event, either it is a positive edge or it is a negative edge transition. So based on that, the changes were happening in this case. Now we can have another information, that is whenever some of the events or some of the signals maintain a logic 1, so that time I can trigger out. I can trigger, or if it is if it maintains a logic 0, then I have to trigger something or some activity has to be followed. So in such case, what I can do is I can go for level sensitive timing diagram. So again in this, what we do is, so here the symbol at the rate is edge sensitive control. So that is either during the positive edge or during the negative edge. So at the rate performs its operation either during the positive edge or during the negative edge. Now, what if I want to perform an activity based on, say, whether it is logic 1 or it is logic 0? So then what I do is I make use of this keyword, that is wait. So which specifies that it is level sensitive construct. So in this one, what is the syntax? Always you wait until this counter becomes logic 1. Until this counter becomes logic 1. So here it is rising and it maintains its level. So that is, it is at logic 1. So when it is at logic 1, after 20 minutes of time, as per this code, count gets incremented by 1. Now, what happens if count is if this count enable is continuously 1? It is continuously 1. So what happens is, after every 20 time units, count gets incremented. After every 20 time units, count keeps on incrementing. So this is what is happening when you use the wait keyword. When you use the wait keyword. So wait keyword specifies that it is level sensitive timing control. So that is what is happening in this case. Okay. So this is pertaining to the timing controls. So these are different aspects what we dealt with. Now let us move ahead and check out what are the conditional statements. Now the first one what we discuss is, we'll be discussing if and else statements. So as you have done in C programming, right? The same kind of syntax and same kind of formats are available in Verilog. So if you want to have conditional executions, right, then you can perform this condition. You can use this conditional statements. So how do I specify in C programming the different aspects? I can have only one single if statement. I can have if else statement. I can have nested if else statements. So different possibilities. All possibilities are present. The same kind of possibilities are even present in your Verilog. So here what we have, the first one, that is only one if statement is there. If this expression is true, then execute this part. If it is not true, then this statement won't be executed. So this is only one if statement which is present, and it is not having any else part. You can have multiple if statements also without any else part. So even that is possible. Now we have the other one, that is which has one if and one else. So it is like if one thing is not true, then what is the default thing I should do? So that is how it goes around. So we have if, then the expression, if it is true, then execute these statements. If this expression is not true and you have specified the else keyword, then execute the rest of the statements which fall under else statement. Now, the third type is consecutive if else. That is, it is ladder kind of thing. So here you have, if this expression is true, then you execute these statements. Else, again you cross verify. If the next expression is true, then execute the next set of the statements. So on, you can continue and have some default statements being executed if all the previous expressions fail off. This is not compulsory. Else statement is say It is optional. Else statement is optional. It is not compulsory that you should put else. Okay. So this is how it goes around. Okay, with the if else statements. Now, another thing is if you have more number of statements within that if or else statements, right, you should put it in the begin and end keyword. So it is like you are putting it in a flower brace in your C program. So you have if statement and multiple lines are there. Then what you do is you put it in flower braces. That is in your C programming, right? It is like if x is equal to 1 and if you have only one statement, then say for example y is equal to 0. So what this specifies is there is no flower brace. What this implies is this if statement is having only one statement within it. It is having one statement within it. The same thing also can be written as I put brackets y is equal to 0. So even this is also having only one statement, but what you have done is you have put flower braces. Even this is correct. Now, what happens if multiple lines are there? Suppose if x is equal to 1 and I want to perform two operations. Say y is equal to 0 and I want to do z is equal to 0. Now, if I don't put flower brackets, right, what happens is this if statement will be having only this statement as its part. This is not part of the if statement. But as per your logic, if this entire thing should be the part of your if statement, right, then you should put a flower brace, open and close flower brace. So this has to be done. So in Verilog, how it is, you have to use the begin and end keyword. You have to use here. You have to use begin, and here you have to use end. And here I can have n number of statements. So this implies that this entire body is pertaining to this if statement. So that is what is happening in if else statements. So here just an example, single if statement, if not lock. That is if there is no lock, then you store the data in the buffer. There is only one statement over here. So the statement is pertaining to this if block. Next, if enable is true, then out is assigned with in. So here also only one statement is there. Now here you can see that if this expression is true, then you execute begin and end. Here you can see that there is more than one line of code or one statement. Therefore, you have to put it within begin and end. Okay. Then, if this is not true, then you can perform some say default operation. This is not. This is optional. This is not compulsory that every if should have a else. Nothing like that. So this is the default statement which will be executed if all the previous statements are false. Now here what is doing here, if ALU controller is 1, then perform say addition. Else, if ALU controller is 1, then perform subtraction. Else, if ALU controller is 2, then you perform multiplication. Now if nothing is specified over there, then what you do is you execute the default statement. So this is multiple if else statements. So this is pertaining to if and else statements. So in the coming classes, what we'll be doing is we'll be looking how multi-way branching will be done, and the remaining part we'll be discussing. So this is all for today. Let us meet again in the next session.